So in the last video, we saw how to calculate the three-phase fault currents of the system. This is the exact same model that I constructed in the previous video. Let's continue with the single-phase short circuit current calculation. If you remember, we had this topology for our calculation. You see, we have delta wide transformer, and what I would like to show on the schematic of the PowerFactory software to show also the vector groups here. And for that, we need to go to the layer section, which should be, or maybe right mouse click, layers. And see, there are two different columns here. One is for visible parts and another for the invisible part. From invisible part, let's select vector groups and bring it to the visible side. Let's also take the tab positions for the transformer. If we do that, now you can see we can clearly see how the configuration of the transformers are here. Now, in order to calculate the short circuit current, similarly, we go to the bus bar for our fault location 1. Now remember, we had 3 different locations of short circuit current calculation. One was, maybe I better show you in that single line diagram. We had one at this point, F1, one for F2, and one in F3. Let's right mouse click here on this bus bar. Similarly, calculate the short circuit current. And now, as I'm calculating according to the standard IEC 60909, I select from the drop-down list of fault type. You see, there are all different types of fault scenarios: 3-phase, 2-phase, single phase to ground, 2-phase to ground, etc. For single phase current calculation, let's choose single phase to ground, and the standard published in 2001 is okay. I will leave the other settings as they are. Let's execute, and here you can see the IKSS for 3 different phases. What we're interested in is the short circuit current of phase A, and also to show the peak current. For that, we need to show what results we want to show them on the dialog box. Let's choose then phase A, SK double prime, IK double prime, and IP. And let's adapt the width. So here now we have the phase A short circuit current with 35 kiloamps, and the peak short circuit current is then 73 kiloamps. And you can also calculate at these 2 bus bars applying the same procedure. Let's now concentrate on, for example, if we want to plot the instantaneous curves of the short circuit process, the voltage and current. Let's choose this bus bar, the fault location F1. Now for that, we need to do a couple of steps beforehand. So we need to come to this bus bar, right mouse click, and we need to define the event. And for that, we go to define, and let's define a short circuit event. Now here you can specify at what time the short circuit should take place. I would say let's take it 0.1 second. And the fault type, there's all different types again. I will take 3-phase short circuit. And that at that point of 0.1 second, the three-phase short circuit happens. And there are additional settings if you want to include the impedance of the fault occurrence. You can add it here, the resistance and reactance values. Let's, for the sake of calculation, consider them to be 0. Okay. Now that we, in the first step, introduced the short circuit event, we also need to add another event specifying when to clear the short circuit. So again, I right mouse click here on the bus bar, define another short circuit event. Now this short circuit event should do the opposite of introduction of a short circuit current. That means clearing the fault. And since we introduced the short circuit current 0.1 second, let's see the results for about a couple of periods. Let's clear it 0.3 seconds. And you can choose if the clearing should take place to the next 0 crossing or immediately. I choose at 0 crossing. That's done. And from here, we need to select EMS and RMT simulation. And we also need to define the results for RMS and EMT simulation. From here, okay. So for visualization, we need another window. And let's input a new graphic here. I'll call it VI plots of short circuit. And a virtual instrument panel is what we need to choose. Execute them. And yeah, let's let them as they are. And here we need to append new VIs. And we can choose what should be the type of the plot. I want to show in the scope 2 different set of values. One set should contain the 3-phase voltages and another set should contain the 3-phase currents. So I take here subplot 2y. Is it? No, subplot v plot, this one, and number of plots is 2. So we have 2 windows here. Now if I double click on the first window, I can select from here all calculations. What should be the element is terminal 1 and variable. Okay. We have only one variable. That means we need to add the variables to plot here. Let's go out of here. To define the variables, let's right mouse click here again. Maybe I skipped that part. Let's go to define results for EMT and RMS simulations. Right mouse click here. And we need to consider the RMS simulations or EMT. Under EMT simulation, and then let's choose show them all the bus bar. Let's take it out and take line to line voltage, which is phase A, B, and C. This I will choose. And also the currents, the phase currents in terms of kiloamperes, 1, 2, and 3. Okay, close. Let's now go to our plot window. Double click here to show the plot on the windows. Let's double click on one of them. From here, select the all calculations And in the element type, we choose the busbar or the terminal one. And then in variables, we can choose what we want to show in the first plot. So let's take the 3 phase voltages for that. Click OK. And in the second one, again, all calculation. In element, terminal 1. And in variables, let's choose the 3 remaining variables, the short circuit currents. Okay. So you see already the values here. The way to do is that you go there, you select first the RMS and EMT simulation, and then pre-calculate the initial conditions by pressing here. Now by default, the bullet stays here, RMS values. In that case, we don't have the instantaneous curves that I want. So we need to choose the instantaneous values, electromagnetic transients, and then need to execute them. And then let's run the simulation. I will take the stop time to be 0.9 seconds and execute. You see, then it is gone. To show the plots fit properly into the windows, let's adjust them, scale x-axis and scale y-axis. So you can now clearly see on top of that at 0.1 seconds, the short circuit voltage is then introduced, all 3 of the phases, and the voltage is 0. Until 0.4 seconds, when the fault is then cleared. And during this space of time, we have the short circuit currents here. If you notice on the red curves that you will have a decaying DC part of the short circuit current, which is typically the case in case there is a short circuit. So this is how we show plots on the results. And you can do it for other fault locations as well. Just repeat the process and you can show the plots here. Thank you for watching.